First thing we have on the agenda is the usual roll call. So, in a slightly different order than sometimes, why don't I start with Mary Waldron? If you identify yourself and by whom you're appointed.
Good evening. Thank you very much. I'm Mary Waldron, and I am representing.
Is that Jack Priest I also see on the screen?
Jack Priest, representing Commissioner for the Department of Public Health Radiation Control Program.
Okay, then let's go do it a little differently. Andrew.
Andrew Gottlieb, Association to Preserve Cape Cod, appointed by Governor Baker.
Greg Wade, representing the Massachusetts Department of Public Utilities.
Seth Pickering from Mass DEP, appointed by the Secretary of Energy and Environmental Affairs.
Mary Lampert, appointed by the Senate President.
Kevin Canty, Vice Chair of the Plymouth Select Board, representative of the Plymouth Select Board.
Jim Lambert, appointed by the House Speaker.
Jim?
You all set?
Yes.
Mary Gatzlick, appointed by the Senate Minority Leader.
Mike Fortini, appointed by the Senate Minority Leader.
Pine DuBois, appointed by the Speaker of the House.
Kelly O'Brien, representing Local 369.
John Moylan, Holtec, Site Vice President.
Dave Noyes, HDI Compliance Manager.
Well, I'm glad to see that we have a quorum. A couple of minutes ago, it was going to be an open question. Okay. Moving on, the next thing is approval of the minutes. We've all seen the minutes. I received some corrections from Dave Noyes. There are a number of typos going through the minutes. Are there any corrections that people noticed in particular, or noticed at all, that need to be corrected? Dave, I have yours. Fine.
Mr. Lampert, I just think in terms of confusion, that it looks like you are noted as the board chair all the way through, which is the first time in any of the minutes we've seen that.
Let's call it shall we call it a panel?
And you can call it a panel. Or if you want to put board chair next to your name at top, that would be okay too.
A panel will be fine, and there's nothing like global replace.
Yeah, and I think Mary Jo should be, what, co-chair or whatever, or vice chair?
Yes, absolutely.
There were a couple of things that I did have questions about. Spelling and stuff like that. Can I just send that to you later? Taurus, for instance?
Yeah, I noticed a number of spelling. I noticed a couple of words that I frankly had to figure out what they really should have been. I noticed
like
that...
the Office of Appeals and Dispute Resolution. Do you have to look that one up?
Well, that one's actually right, for a change. And basically, they got my name right, they got my wife's name spelled wrong, even after 50 years, so I guess that's all right.
Yeah, that was it. I had some questions in terms of the follow-up, but that's it for the minutes. Thank you.
With the various corrections in
No,
spelling...
I had two
Yes, ma'am.
issues.
I'm sorry.
One dealt with the donut hole.
Yeah, where are you in the minutes?
Well, probably they weren't numbered, so I couldn't figure it out. So you just have to Google donut hole. The issue...
It's on the next to last page.
Yeah, feels that it says, feels that the issue is not properly addressed by monitoring wells to determine what's there. What should be pointed out is what the question and issue was, that the monitoring wells do not show what is there, if anything, and whether packaging is intact. This assumes, by having monitoring wells to the east of where it had been reported chemical waste was buried, that the monitoring wells would only indicate there was an issue if, in fact, the packaging had been breached and it happened to flow towards the monitoring wells. It's an important issue, particularly to Plymouth. The town of Plymouth has shown interest in buying that land, and you wouldn't want chemical toxic waste be left on site. And so therefore, it's called a shovel, and to determine whether and what is there and to deal with it.
My recollection
And it
is
was
that,
discussed at 1 minute, 1 hour, 40 seconds to 1 hour, 43 seconds on the video. Down maybe 4 lines, the basement inventory model at 1 minute 51 seconds to 1 minute 55 seconds. I asked that the basement inventory model be defined, and that question was never addressed. What was said in the minutes was they're required to follow NRC requirements and models. However, what was mentioned was that the basement inventory model is in the settlement agreement, which is a very important point. So I'd like that corrected also. That's the end.
any other additions or corrections to the minutes? Yeah, she's on page 6.
Oh, and in the minutes?
Before we post them, I will get page numbers onto them. And if I forget, somebody can repost them. All right, with the suggestions and corrections, and people are going to give me the typo ones, do I hear a motion to approve the minutes as corrected? Mr. Fortini, a second?
Second.
Excuse me, did I hear a second?
Yes.
Okay. All in favor, and since this is visual, we have to take a roll call. Mary Waldron? Is that aye?
Yeah,
That is aye, yes.
Andrew?
Yes.
Mr. Wade?
Aye.
Mr. Pickering?
Yes.
Mr. Priest?
Yes.
Mrs. Lampert?
Yes.
Mr. Canty?
Yes.
I am yes. Mr. Gathlick?
Yes.
Mr. Fortini?
Yes.
Ms. Dubois?
Yes.
Mr. O'Brien?
Yes.
Mr. Moylan?
Yes.
Mr. Noyes?
Yes.
Okay. Motion passes. I got him.
Mr. Chair,
Yes.
this is Chris Callahan. I'm joining late. My apologies. I just want to let you know that I'm here.
Good. Are you on the screen somewhere? Here, you've got him up, okay. Moving right along, where I'm happy to have with us tonight Dr. Buesler from Hui, and coming in on Zoom will be his associate, Dr. Rapina, also from Hui. The subject on the discussion is, you'll see it up there actually on the screen because I got it from him, transport and fate of radioactive contaminants in and around Cape Cod Bay. I will ask people to hold their questions until the end, because it's amazing how many times your questions get answered in some later part of the presentation. Dr. Buesler? Is the red light on, or green light?
Now it's on, right? Everybody can hear me? Thank you. And thank you for inviting me and everyone for their attention tonight. It's going to be interesting. I'm looking forward to this. You're going to hear from me, Ken Bissler, more about the chemistry and radioactivity. That's my specialty. And Irina's going to be on Zoom. Unfortunately, she couldn't make it tonight, but her slides are all part of the same slide deck. So we coordinated our talk. Should be under half an hour and time for question and answer after that.
And I believe she's on the screen.
There she is, Irina. To give you an idea what's to come, I'm going to cover those first 2 topics, introducing where I work and myself a bit, and then just some real basic background on radioactivity in the ocean. What does it really mean? Where does it come from? That's after about slide 7. I'll introduce Irina. I'll be running her slides, and she's going to talk more about her work as a physical oceanographer studying transport currents in and around Cape Cod Bay relative to this site and potential releases. Comes back to me, look more about the fate of those radioactive contaminants because they're not all the same. And then we'll get more into what came up, I guess, at your last hearing, a report I wrote about 1.5 years ago on the levels on the site today and what that means for the ocean. So that's 24 slides. Let's just get right to it. WHOI, I'm surprised maybe not everybody knows Woods Hole Oceanographic Institution as WHOI, but about 1,000 people work there, about 45 minutes, not too far down the road. We have about 150 scientists and engineers like myself who are very independent. We do our own work, whether it's biology, chemistry, physics, geology, or engineering. And we work at this non-for-profit basically for the love of science, and we like what we do. We tend to study different things. My specialty, as you'll see, is radioactivity. We follow codes of conduct, but we have very much independence in terms of the work we choose to do. WHOI's position, as it says, is kind of to lead, tell about the science, not to make the decision. So I'm here in that vein to provide some science insights, not to make any decisions about what might happen here along the coast. So that's the introduction to the Woods Hole Oceanographic Institution where I work. More about me. I've been doing this since the 80s. I came out to the Cape Cod as a graduate student and basically never left, so I must like it here. That picture shows me on a boat. I go out on boats. I'm an oceanographer, and I'll be taking samples, typically bringing things back to the lab to analyze for low levels of radioactivity that are everywhere, and we're going to talk a bit about that. That particular picture is from 2018. Fukushima Daiichi nuclear power plant is behind me. We've been going there ever since 2011 for that particular case to look at radioactivity, where it ended up. Dissimilar than this in terms of the scale, but some similar questions have been asked there. I'm also director of an independent center, Marine Environmental Radioactivity. A lot of my work these days relates more to that third bullet, carbon cycle. I use naturally occurring radioactivity to study carbon and nutrient cycling in the ocean. But today we'll talk more about human-made radioactive elements, and we'll talk a little bit where they come from, but things like residue from the nuclear weapons testing and things like Chernobyl, Fukushima accidents and things like that. So that's what I'm going to do. And I think I should just get right into a real basic slide. You know, I often say we live in a radioactive world. We can't avoid it. There are thousands of different of radioactive compounds, elements. I'll use the word radioisotope most commonly around us in this room, in the materials and what you eat. Just want to point out they can be generally classified as naturally occurring, things that come from rocks on Cape Cod. Often it's radon in your basement. Heard of that? Some people have to mitigate for that. That's a naturally occurring radioisotope that happens. Cosmogenic, did anybody see the northern lights that we had a couple weeks ago? High energy particles in the upper atmosphere create radioactive isotopes. Tritium, carbon-14 are examples. We're mostly interested here today on human-produced isotopes and their fate in the ocean. But they all have some similarities. There's really sometimes no distinction between them. An odd thing, too, about radioactivity, as you know, it can be both harmful in certain amounts and certain types, and very beneficial in terms of things like medical procedures or power, things like that. So there's two sides to most of these radioactivity stories. We're going to hear a bit about that. And, you know, another thing is you can't touch, you can't feel, you can't taste radioactivity, right? So it's often hard to comprehend differences in levels the way you can like temperature and things like that. So that's another thing. We use different units, and I'll try and be as simple as I can when I compare like what's in Pilgrim today versus what's in the ocean. And so we're going to look at relative levels mostly, trying to keep away from a lot of the units that can confuse even people like me when we talk about radioactivity concentrations and things. But they're basically going to focus on these three, and mostly human activity is what this group is concerned about. So let's just introduce what's in the ocean already and where it's come from. And that big circle, we're going to just talk right now about one radioactive isotope of cesium, cesium-137, 30-year half-life. Size of the circles kind of give us a scale, and those big numbers, the amount of petabecquerels, well, there is a unit there, but look at that 950 number. How much is in the environment, and where did it come from? Well, we've been testing nuclear weapons since 1945, right? Most of the input was in the 50s and early 60s, and that source released globally close to 1,000 petabecquerels of radioactive cesium-137. The circle's kind of 2/3 of the way in the ocean, line there, and 1/3 out, because most of it fell in the ocean. This planet is 2/3 covered by oceans, right? So this would be distributed from atmospheric tests. There were about 500, and they lasted actually up until the 90s, really the last ones. But that is often by far the largest source globally. We call that global fallout. So other things happened. 1986, I was a student when Chernobyl accident happened. 85, about 10 times less cesium-137 was released from that accident. So that was mostly on land. That's why that's a little bit above the waterline. But that's something that was very large for that time and for this type of accidental release. And then along comes Fukushima Daiichi, the disaster in Japan in 2011, the earthquake, tsunami, loss of power, and this massive release into the ocean. This was a power plant right on the ocean, unlike Chernobyl. And it's about 4 or 5 times less of the isotope cesium-137. So there's some kind of scales. Relative to each other, weapons testing is large. But another point is all of these have multiple isotopes. It's not just cesium that's released in a nuclear weapons test from a reactor accident. Here are just 2. We're going to talk today mostly about cesium, but also about tritium and strontium-90. So in those same units, much less of those released. That doesn't mean that they're of less concern. It just means the total amount from Fukushima in 2011 was much smaller. I didn't put 3 Mile Island up there. You can't make a dot that small. For cesium, that's 0.00001 petabecquerels. I might have gotten one of those wrong, but there's been other sources, is what I'm trying to say, but they're usually much smaller than these, and your source here locally is much, much smaller. But globally, this is what we have to think about when I take a sample from Cape Cod Bay right now. Where is it coming from? Mostly the weapons testing. The other interesting thing is it's kind of hard to make these measurements because there's a lot of naturally occurring, we often say background radioactivity. Uranium-238, potassium-40 are well known, again, from weathering of those rocks into the ocean. The ocean's salty because of weathering. It also has uranium in it, potassium, much, much higher levels. We don't even think about that when you go swimming, boating, but it's there. My challenge as a marine radiochemist is measuring these small amounts of radioactivity that are human-made in this natural background. But that's there. So when I say we live in a radioactive world, we have a radioactive ocean, that's typically what we're talking about. So this is where it's going to get interesting. I hope, what happens to all this radioactivity? Where does it go? And I put this word, it all depends, because it's not the same whether it's cesium, strontium, or tritium. We're going to hear from Irina next after this slide about her work on the transport of these isotopes with ocean currents and dilution. I'm going to come back and talk more about the accumulation of different isotopes in marine life in particular. We're going to talk a bit about the deposition, accumulation on seafloor sediments. They don't all move with the water. And there's, of course, radioactive decay properties. They decay at different rates from really less than a second to millions of years. So it's important to know that property as well when you think about how long will this be with us. Because if you do nothing, basically, radioactive decay is the one process that always will reduce the levels with a characteristic, we call it half-life, how long till half of that isotope disappears because of its radioactive decay properties. And I'm not going to get much more detailed than that. I think I'm going to go right to Irina, who is on the Zoom screen behind us, and she'll be speaking, and I'll be trying to switch the slides for her. Irina, the floor is yours.
Thank you, Ken. I I cannot see the slides because my screen. Thank you. Now I
Could you
can see
turn up your
them.
mic a little? Or maybe we can in the
You're a little bit
control.
hard to hear, Irina, and I can tell you what's on the slide. How about that?
Yes, that sounds good. Can you hear me now? Can you hear me well now?
Yes, we can.
Wonderful. So my name is Irina Ripina, and I'm a physical oceanographer at WHOI, where I've been working since 2008. My main topic of research is transport of water masses, water properties, and tracers in oceanic flows. And here the term tracers applies to anything that can be advected and transported by oceanic currents. And this applies to radioactive wastewater, but it also includes biological tracers, for example, little fish or fish larvae, things like harmful algal blooms, microplastics, or even people that fall overboard, as in search and rescue operations. Next slide, please. So today I wanted to tell you about the results of our recent study of transport in and around Cape Cod Bay. This work was funded by Sea Grant. The study focuses on pathways, investigating the pathways of the proposed wastewater release from the Pilgrim Nuclear Power Plant. The study is based on a model of ocean currents, and one of the questions that we focus on is trying to understand whether after the release, the radioactive water would flow towards the inner bay coastlines, or instead whether it would leave the bay without coming close to the inner bay coastlines. So the bigger picture that you see on this slide shows the model domain, and it's very large, much larger than our domain of interest, which is Cape Cod Bay and the area around it. I'm not sure, you cannot see my pointer, but maybe you could point out where the Cape Cod Bay is in this image. So the model that we are using is an operational model, numerical model that has been run by NOAA, and it has realistic forcing and resolution of 700 meters. So basically we know oceanic currents on a grid covering this domain, and we know the grid spacing is 700 meters, and we have an estimate of oceanic currents every 6 hours. Next slide, please. So in our study, we decided to take a statistical approach where we repeatedly simulated the wastewater release every 6 hours for 3 years. And this gives us a lot of simulated data showing where this wastewater plume will be advected in our model. From this large amount of simulated data, we can produce maps like these ones that I'm showing here. The top 4 panels correspond to the most likely spreading pathways maps. So they show the probability that a water parcel that is released close to the Pilgrim Nuclear Power Station will visit different locations throughout the domain of interest. Larger probabilities are highlighted by yellow colors, smaller probabilities are blue, and if none of the water parcels visited a particular location, a particular bin, that bin is white. So white corresponds to 0 probability of encountering the wastewater. The 4 panels from left to right correspond to different seasons. winter on the left, then spring, summer, and fall. And so two things that I wanted to point your attention to in these maps is that in all seasons, we see a high probability that the wastewater that's released close to Pilgrim Nuclear Power Plant will come close to the coastlines around the bay, within the bay. And this is reflected by yellow colors. You can trace the yellow colors continuously from the red star, which is the location of Pilgrim Nuclear Power Station, all the way to coastlines near Dennis, Wellfleet, and Provincetown. On the other hand, the colors outside of the bay contain very little yellow, which means that the probability that the wastewater will be advected out of the bay is much smaller in all seasons. Now, if you look specifically at different seasons, then we can see that in winter and fall, the spreading pathways are different from those that occur in spring and summer. These are the two inner panels. In winter and fall, there is almost no yellow and even blue colors outside of the bay, which means that the transport out of the bay is very, very low. But in spring and summer, we do see more colored beams outside of the bay, which means that we have slightly higher, still low, but slightly higher probability that the plume will be advected out of the bay. The other thing that we can see here is that the pathway for the plume to get out of the bay is as follows. The wastewater will initially get advected towards Provincetown, where it would curve and get in the channel just north of Provincetown and hug the coast, and then get entrained into a southward current that flows along the outer shelf. And so this outer current would then advect the wastewater along the outer coastline. When we talk about probabilities, it's also important to talk about associated timeline or time scale. So the 4 panels on the bottom show the travel time in days that correspond to the upper probability map. And here the travel time gives us the time that it takes for a water parcel that is released close to Pilgrim Nuclear Power Station to get to different locations in and around the bay. And so the color bar here is in days, and you can see that it takes approximately 3 weeks for this wastewater to cross the bay and get into the eastern elbow of the bay. And on the other hand, the more direct route towards Provincetown only takes a week or less. Next slide, please. One question we were interested in is, what is the cause, the main driver of this seasonal change in transport pathways? And an obvious candidate is wind. And indeed, if we look at wind conditions in this area, then the wind conditions are very different in winter and fall versus spring and summer. In spring and summer, we have the dominant direction for the wind is to the northeast, and the winds are fairly weak. And then on opposite, in winter and fall, the dominant direction changes to the southeast, and the winds are significantly stronger. And so what happens here is that in winter and fall, the stronger southeastward winds push the water more into the bay, and that leads to the close-up of the out of the bay transport pathway. Next slide, please. So in summary, we have seen, based on a numerical model of ocean currents, we have seen that the probability of a plume that is released near Pilgrim Nuclear Power Station The probability of this plume coming close to the inner bay shoreline, including coastal waters of Dennis, Wellfleet, and Provincetown, is high. And on the other hand, the probability of a plume leaving the bay without first coming close to the inner bay shoreline is low. We also see that when a portion of a plume leaves the bay, it always does so by passing north of Provincetown and then flowing southward along the outer cape. We saw that the spreading pathways of a plume depend on the timing of the release. Specifically, in winter and fall, the probability of leaving the bay without coming close to the inner bay shoreline is very small and gets slightly larger, still small, but slightly larger in spring and summer. And we saw that the seasonal differences can be linked to wind conditions in the area. Next slide, please. And so this is my last slide. I just wanted to tell you a little about future research questions that we're thinking about. First of all, we would like to analyze other years to check that the picture we got is robust and is consistently repeats itself from year to year. The second research direction is to look at transport in 3D, because so far everything I showed you today was confined to the surface few meters of the ocean. So that's the transport within the top layer of the ocean. But in reality, water can subduct, and also some radionuclides that are heavier than water can sink. And so we would like to reinvestigate transport in 3 dimensions. And finally, it would be nice to redo the analysis using a model with higher resolution. And this would allow us to better understand the details of the spreading pathways, especially when the plume comes close to the coastline. Thank you. That's all for me.
Thank you, Irina. We'll move on then with the last 8 or so slides. So back to this slide. What happens in the ocean? Well, you just heard a very good physical oceanographer would tell you where the currents would take radioactivity relief from a site here along the coast. We're going to get into the next bullets in these next few slides. But it's a really basic level talk. You know, you could get a marine radioecologist spending their whole time talking about any one of these isotopes and their uptake in this case, fish as this example. We're going to focus mostly on tritium, cesium-137, and strontium-90 and talk a little bit about the difference because they behave very differently because of their chemistry and their uptake. Tritium is that hydrogen, radioactive form of hydrogen, so it behaves a lot like water. So if you took a fish that was exposed, put it in a clean tank, let's say an aquarium, you put tritium and a fish in. People do this, radioecologists, right? And they say, well, how long until it passes through? If we stop adding in the source, it's very fast. It's like water. It goes through us very quickly. Humans have this same kind of time scales. Not exactly. Juvenile fish are different by weights, but generally it's very fast to transport tritium through biological systems. Cesium behaves a lot like potassium. Think of your muscles, think of electrolytes, drinking Gatorade. So that goes in and stays there for weeks, a bit longer. So that's something we should know about. We should think about the differences. And then strontium-90 at the other extreme, it says years up there. That can be many months and years, it depends. But basically, it replaces calcium. It has the same chemistry. And so in your bones where you have calcium, you would accumulate strontium-90 if that were in the water, if you were exposed. It was used, people used teeth to study levels of strontium-90 during the peak of those weapons testing years. But that takes much longer for it to be out of the system again. So 3 different forms behave very differently. We could go through a whole litany of these, but we'll just focus on those. Another difference between them, apologize if you haven't become familiar, that's tritium on the left, our friend cesium in the middle, and strontium-90 on the right. And this is just a plot thinking about what is the propensity for tritium to accumulate in biology, the blue, or in the sleep voice sediments. That's number 1. It's about an equal propensity. If you put it in the concentration in seawater, would equilibrate with the seafloor or the marine life with a factor of 1. So it stays about the same. it's low on here, and we're going to look at a number of different elements later. But if you think of cesium, it's about 100 times more likely for the same level of cesium to accumulate in fish, and it's 4,000 times more likely to accumulate on seafloor sediments. We call that sediment partitioning. Strontium-90 is somewhere in the middle, maybe 3 times higher, 1-for-1 for tritium, 3 times higher for strontium for the same level in the ocean, and about 8 times higher on the seafloor. And the reason why that's important there in the bullets is the higher that number is in blue, the higher potential you would have for accumulation for the same levels. We're going to talk about what the levels are next. And for the sediments, if you have something with a high sediment partitioning, that means it's likely to accumulate on the seafloor. It wouldn't just move with Irina's model. So Irina's model would do a, I'll say, perfect job. She's a good scientist of describing the fate of tritium, but not these other isotopes. They would behave differently. And so that's something to think about when we're thinking about what's in the source water. So I guess at your last hearing, the next slide is what I wrote, but I was looking a year and a half ago at this report because when I heard there's 1 million gallons to be released, first question is what's in the water? And it took a lot of time for me to find that out. I found some of that information in this report dated, was that May 18th, 19th, 2023. And this is when samples were taken in 3 different locations and shared between state labs and Holtec to see what the levels are. So these are not my data. This is looking at the report because I was asked, well, what does this mean? So a week later, I decided to write down my findings, and I think that's what was read into the report. Be aware, again, this is what's in the report, and there are analyses from 3 different locations within the nuclear power plant. I'm not a specialist in nuclear power plants and reactors, so don't ask me about these locations and why some are higher and lower. They're all pretty similar in those different locations, so this is just one of the tables from the spent fuel pool. I noted, realize H3 is tritium, cesium's on the bottom. They looked at 5, they report on 5 isotopes. Tritium that measured by one set of methods, the others are gamma emitters by another set. They didn't measure every isotope that was there. But at the time it came out, they also used units of microcuries per milliliter. That's not something I use in science. It's a unit that's familiar in the nuclear power industry. It's reported in scientific notation. I don't think everyone in this audience knows how to read that and realize that a minus 0.5 is 1,000 times smaller than minus 0.2, right? These are set up in a scientific notation used by engineers around the world. Nothing wrong here. But the main news that came out was that, yeah, they kind of agree. When the state did their analyses and Holtec, they got pretty similar numbers. The biggest number on here, by the way, is cesium-137. 1 times 10 to the minus 2 is a very similar number. This would be 0.7 times 10 to the minus 2. So Mass and Holtec agreed, right? Results are typical of nuclear power plants. This was nothing that was unexpected. I think it is worth reporting that this is a small set of radioactive elements that are in these power plants, this type of water. In Japan, we're often looking at 56 of these. But these were representative. If you see high levels of some, you expect high levels of others. But one thing for me, when I put them in, I'll go in my report, they're much higher than in the ocean, which is also expected. It's not unexpected that the levels inside cooling waters and things in these locations would be much higher. But the question is how much higher? I get getting asked this. So what I did and put online 1 week later was an analysis where I looked at, I'm only going to show you tritium and cesium. I'm going back to my more familiar international unit of a becquerel per liter. It's a decay event per liter, which is about 1/4 gallon. And you convert those numbers into units that I recognize. And I said, well, look, how does that compare to, say, a drinking water standard or what I measure in the ocean? That's really the number I knew about. And you can see already these are quite high relative to each other. So tritium, if you look at that number and you compare it to that drinking water limit, it's about 161 times, well, it's exactly 161 times higher, and it's over 1 million times higher than the ocean. That was part of what was read into the record, I believe, at your last hearing. Cesium, those numbers are over 40,000 times higher than a drinking water standard. I know there's different drinking water standards around the world. These, I believe, are the US standards. In Europe and Japan, they can be slightly different. But really the number to look at is what's in Cape Cod Bay right now, 0.002 of those units. So this is the 200 million times higher number that was read into the record. So these are very high numbers relative to the ocean. There should be no controversy there. And it's, again, not unexpected. And this slide, I think, is important too, because in my same report, I pointed out, I mean, no one's drinking seawater directly. Sometimes people treat that. No one's drinking your wastewater directly. This is untreated water. The report talks about this as before release, before treatment. But that last point is what I reiterated, is that, of course, you don't want to. It reinforces the idea that you don't put this direct in the ocean before extensive cleanup. Something that's 200 million times higher than what's there. Dilution will help, but I think I've shown you that sometimes it's not just dilution, it's accumulation, other factors that go into understanding the fate of something like cesium in the ocean. So I don't think there should be any controversy around this type of statement. I do want to go back to, as we start closing this out a bit, but does it matter then, Ken? Who cares? Well, I think it matters because if you look at the 4 isotopes in the report, there's a lot of differences between them in terms of the increasing health concerns. Tritium here has the smallest, what's called a dose coefficient. It's a measure of safety. The amount of dose per becquerel is quite low. It already had those low uptake on seafloor sediments. And so it tends to be of the least concern, tritium, from any, whether it's a weapons test or whether it's a nuclear power plant. But then look here at our friends, manganese 54. We haven't talked about cobalt 60 or zinc. Here's cesium 137. So in terms of just their relative safety dose, and it's more than that, there's target organs. I tried to convey that a little bit. But basically, they all are much higher by factors of, say, 10 or 100 or more. The things about uptake into fish, I said cesium was 100 times more likely to end up in seafood products. Some of these are multiple hundreds, 2,000 times more likely than tritium. These are relative. So it also depends upon what's put in the ocean. But that's a big difference. Here we have this seafloor accumulation number. Manganese, 2 million times more likely to end up in seafloor sediments. So where you put a liquid in a discharge pipe, that will interact with the seafloor and remain localized or move with sediment around the bay. Very different than tritium. All of these are quite different. And half-lives range from under a year to 30 years for cesium. And again, there's more isotopes. So yes, it matters. There's different health concerns, different biological accumulation, different seafloor floor accumulation, and different times for radioactive decay if you just to hold on to the water. So really, to round this out, I've got 3 slides with kind of conclusions. I hope we've walked you through, but it's, of course, much more complicated than what you're hearing tonight. But Irina talked about the transport with currents and that the waters remain for weeks, potentially more, in Cape Cod Bay if released from this site here at Pilgrim. Another thing I want to say is that the expected dose, so a measure of certain health damage, is going to be quite low, right? It will depend on the cleanup. You don't want to be exposed to water that's 200 million times the levels that we're experiencing now when you go swimming. Dilution will take care of some of that, but a lot of the dose will depend upon the details of the cleanup. Is the release done all at once over time? That's in some of these reports. I know it's being discussed, but that means I can't really say much about it until we see more on that, and I know there's been proposals. What else? Well, there's differences in accumulation. So that cleanup, if you remove all the cesium and not the tritium, that's one thing. If we have other isotopes, strontium-90 wasn't in the report. I don't know how much strontium-90 is in that water, so I would say I don't really have enough information to assess the impacts. But if you were to release things that have multiple forms of radioactivity, you would probably want to assess those before, during, and after any release, and not just tritium, because they behave differently, not just seawater, but seafloor sediment, sea life. That would be my opinion as a scientist anyway. This last one, actually there's one more slide after this, is, we're talking about putting radioactive material in the ocean. I can't do that from a research vessel. You could not put this water on a ship and take it to the middle of the ocean and release it. That is not allowed. Since the 70s, we have protocols against putting nuclear waste in the ocean. Is this waste or not? I'm not a legal scholar, but to me it's a very different situation when a power plant is no longer providing the public benefit. And so in this case, it's material going in the ocean that couldn't go out on a ship, but the idea is could they put it in the pipe and under some variation, I guess, on a permit for an operational reactor, release it. But to me, that sets a precedent. We don't want to use, in my opinion, the ocean for putting in radioactive waste materials. Yet I truly realize that nuclear power plants around the world do this all the time for the benefit of providing carbon-free electricity, right? To me, these are two very different scenarios. Again, legal scholars probably have a different opinion. And then finally, there are other options. We've heard a lot about releasing 1,000 gallons. What's going to happen? Well, if you were to remove, I don't think I've emphasized that tritium is very difficult to get out of that 1 million gallons because it behaves like water. But some of those other isotopes are not that hard. Maybe you don't get 100% out, but cesium is pretty easy to get out, and some of the other ones. So if you just cleaned up the things that were more harmful on my list, you would be left with water that's largely tritium. That hasn't happened yet, as far as I know. And you could hold that for its decay, 12-year half-life. So we are talking out, say, 60 years. So 12 years from now, half of that will be gone, no matter what happens. That's the radioactive decay process of tritium. Another 12 years, 24 years, is 50% less. 36 years, 12.5%. 48 years, we're down to 6%. You go out 60 years, there's only a few percent left. So one option is holding for decay. When we looked at that option off Japan, which was very earthquake prone, we also suggested using it to make concrete, something that's more stable. That could be done, that has been done. But basically there are other options that I think could be on the table, have been considered. There's different costs for this, but we're talking about a site where they presumably have to maintain the high-level waste for decades, centuries, and beyond until we have permanent waste disposal for commercial reactors. So I do think there are other, it all depends how you're looking at this, options for this type of material. So with that, that's my last slide, and I don't know how you want to, Jim, take questions or how you want to work
I
this.
think I'll start off by asking if any panel members have questions. Ms. Gatzlik.
Thank you very much. Thank you for presenting to the panel. I appreciate it. However, I do have a couple of questions for you. You had an article in 2018 with Surfside, and that's with songs. You talked about the release from songs. And during that interview, you said that the water basically released in the plant is like no big deal. So what's the difference between the water being released from songs and the water that Holtec has proposed of being released from Pilgrim Station? Easy.
Well, I've already said that I expect the dose to be low. You will be able to swim, you'll be able to boat in Cape Cod Bay if this were released. But I still don't necessarily think that's the only solution. And if it were to be done, that we should be doing a better job of monitoring those things like the biological uptake, the seafloor accumulation. And that should accompany releases like this, in my opinion.
Okay.
So that's the difference. I've never said the entire Cape Cod Bay is going to be destroyed in our backyard, but I think there will be concerns about the fate of the non-tritium isotopes that are often ignored in this type of discussion.
The other question I have for you, you were talking about the probability of the plume leaving the bay without coming close to the bay, inner bay shoreline is low. How low is that? I mean, it's a matter of how the current is flowing around the bay, correct? We've been told that before. So it does occur, correct? It's not like it's never going to happen.
Irina, I think that's a question for you. The probability of leaving the bay, she said, it will happen at some point, right? There's a probability of leaving the bay?
Yeah, so I can take that question. In our model, we see that over the 3 weeks after the release near Pilgrim power plant, about 80% come close to the coast. 80% of the probability of 80% wastewater would come close to the coastline. And in our model, because of the resolution, once the wastewater comes close to the coastline, we cannot really tell how long it will spend there and what will eventually happen. So if we want to know what happens to that wastewater that does come close to the coastline within the bay later, say, over several months or years, we would need another, not better, but high resolution numerical model to answer those questions.
So I wasn't sure, but I thought I understood that you said the probability of it being discharged without coming too close to the shoreline is greater for during the spring and the summer?
That is true. The probability of leaving without coming close to the shoreline is definitely greater in spring and summer, and we see this consistently over the 3 years that we analyzed. But the probability of leaving the bay, even though it's greater in spring and summer, is still very low compared to the probability of coming close to the coastline, even in those 2 seasons.
Thank you.
Mrs. Lambert?
Yes, I have a couple of questions, but I do want to say, comparing songs in California to Pilgrim is sort of apples and oranges, because at songs, they had a 1.5-mile pipe into the Pacific Ocean where they were making the discharge, not directly from the reactor. And I noticed that the Pacific Ocean is not a semi-enclosed bay, and so therefore it's rather a different situation. But 2 questions for Irina and 1 for Ken. What I didn't see analyzed was the sea breeze effect in summer late spring, summer, early fall. The sea breeze effect was studied by Mass Department of Public Health when they did the adult leukemia study, pointing out that when the land warms up, that the initial breeze will be offshore. Anyone who sails or goes to the beach knows that. And then as the land warms up, the breeze comes back to the land and hugs the coast. In this area, from Plymouth up to Scituate, that is why Mass Department of Public Health focused the cancer studies on those towns. And so Dr. Bruce Egan has written extensively on the sea breeze effect. And I think that's very important in bringing contamination back to the shore in the warmer weather. Also, I was concerned about the impact to Stellwagen Bank. When the water goes offshore, you said that it doesn't go too far. How far does it impact Stellwagen? Those are the 2 questions for you.
Yeah, I can try to answer. So starting with the sea breeze question, the model does have realistic winds. So it's the limiting factor is, again, the resolution, both spatial and temporal. But the model uses realistic winds, so all the effects of the winds on the ocean and then the effects of ocean on transport are there within the limits that the model can handle these processes. And then the second question was about the transport as the water, the portion of the plume that leaves the bay as it gets in the channel offshore of Provincetown. The question was how far. The details, so the maps that I showed are the results from my simulations. So where you see those brighter colors, those areas have higher probability of encountering the wastewater. So where the colors become faint and turn to blue and white, that's where the probability becomes very low. So basically, where you see the colors offshore of Provincetown, that's where you would expect, or we would expect, to encounter the wastewater.
Okay, and for Ken, you were talking about uptake in fish, and the pictures were finfish. What about the filter feeders? I would think
it does
they'd be more
depend.
impacted.
Fish get their sources either drinking, because they drink water as well, or their food. So for isotopes that concentrate in the seafloor, the bottom-dwelling demersal fish would have higher concentrations. Say, that's what was observed in Japan, for example, when they separated the pelagic surface fish from the deep bottom dwellers. They had higher levels than ones on the bottom because of additional exposure. Their food supply presumably comes from the worms, the clams, the things they're eating.
And also, you were saying the tritium goes through fast, but being a beta particle with a maximum energy of 18 electric volts, sort of lazy, so unlike bananas that have a very high energy, so it beats it out of the body real fast, a fast runner. So I would think the electric energy of tritium and being a beta particle gets an important coloring to the subject. That tritium is not as
It's one of the
mild.
reasons why on tables like this, the levels here consider less health concern for tritium compared to something like cesium or strontium, other isotopes that aren't on this list. So yeah, and this is, people have heard about organic tritium, this is the inorganic form. There's other forms of tritium, and that would stay in longer, but that's usually a small percent of the total tritium when it's released to a lake or an ocean, something like that.
Okay, thank you. And one last question. The samples that Holtec and the state took, it was concern that they came from the middle of the tank. I know Dave Noyes pointed out that they agitated the tank, but in my non-scientific mind, the heavier isotopes, particles, are just like, a ruptured tea bag that winds up in the bottom. And so shouldn't the sample be taken from the bottom of the tank?
I can't speak to the homogeneity in there, and if there were particles in there. When you say heavy, people often confuse that cesium-137, it's not because it's heavy that it behaves differently, it's its chemistry. It does have more protons and neutrons, but it's not the weight that brings it down there, it's its association with particles. So if there were particulate matter in there that wasn't filtered out, and that was on the bottom, that might give you a different number, but I'm not able to speak to it that
Okay,
simply.
thank you.
Mr. Chairman? Oh.
Yeah.
Well, somebody's got their hand up on remotely as well, and I have a question, but I can wait until.
Why don't we take yours?
No, it's all right. These guys have their
We
hand
also
up.
have some hands up over here.
I'll be pretty quick.
Sure.
Just a quick question on the Met data, the windrows. Where did that come from? Like, what was the location? Is it really representative of what we're looking at?
Yes, the question, I can take that question. The question about the wind conditions.
So where was
took-
that Met data monitored physically?
Yes, we looked at 4 different points within the bay, and they all showed very similar wind diagrams. The particular one that I'm showing here was taken in the middle of the bay, but the 4 points at other locations were all both quantitatively and qualitatively similar. This is pretty uniform. The winds are pretty uniform across the bay.
Okay, I'm not sure. So was that monitored in the bay, or did that come from?
This came from the model, so we are using the model of ocean currents, but the as a boundary condition, the model uses wind forcing. And
But your
we are
wind
using-
directions and speeds to develop these windrows came from where?
From the model. This is part of our model. This is
What
part
was
of the
input?
model.
Yeah, but so what was the input
variables
to the
that are
model?
saved. This is the model this is operational model run by NOAA. It's called GOMOS.
So it's not actual Met data from a monitor?
I think the model uses the metadata from
Okay,
monitors,
yep.
but
So my question would go to, what metadata did you use? Where did it come from? So if you could find that out, and that's what got plugged into the model, that's what I'm asking.
I can look up what exact data the model is using for atmospheric forcing.
Okay, well, my question goes to the concern that it needs to be accurate with, the conditions in the bay. So that's the reason I'm asking. So where did it come from? So then I have two other quick questions. Do we know what the volume of water is in the bay? In total?
If that's the question for me, I don't know the volume. I haven't calculated the volume of water in the bay.
Yep, my follow-up question to that would be, how long does it take to get one complete change of that volume?
I can try to partially answer this question. First of all, if you're talking about volume, then we need to talk about three-dimensional transport. And what I showed today only applies to two-dimensional transport in the near surface layer of the ocean. And then the second question, in the model, within that near surface layer, we did look at the time we did look at maps that show how long would it take for a water parcel that starts in any location in the bay to leave the bay. So I think that's the map that you are asking about.
If I could follow up for just a moment, Pine, you basically had a 40-year, you said something about 40 or 50 years. Is that enough? No?
Over the course of time of Pilgrim's operations, which was 40 or 50 years, at 400 million gallons a day, which was the discharge, we would have gone through the bay once.
Thank you.
But I can't verify that.
No, but it's as good a number as we've heard. Mike?
So thank you for coming, Doctor. The observation I have is that, I guess in your slide, it showed the sample was taken based on the water that's now existing in the plant, right, before filtration. And I just want to be clear that numerous times Holtec has advised us that the water would have extensive filtration before it be discharged into the bay, if it were to be discharged into the bay, meaning that all of the pollutants, contaminants, and every radionuclide except tritium would be removed before it would be put in there. So cesium would not be part of the discharge. Is that clear?
We haven't, yes and no. It's clear, and I've said this several times, that this was untreated water, as you said. I don't know the level of treatment, right? I think there was a quote, and I said if you take out 99% of it, that's not going to be, reduce it from 200 million times higher to 2 million times higher, right? So are we talking 99.9999? The experience, Fukushima Daiichi, varies batch to batch, year to year. So it's definitely going to be much, much lower than the numbers they have. That's why it reinforces the idea that you would have to have extensive cleanup. Tritium, as you said, would not follow that. Tritium is very difficult to remove, not impossible, but very unlikely to be removed by any great degree. So you're correct.
Dave, did you have a question?
Thank you.
I do. Thank you again for being here. First question for Dr. Rapina. What constitutes a plume? How much volume in order for that model to be accurate? Are we talking about 1 million gallons, 20,000 gallons? What goes into the assumptions associated with your plume modeling?
I think your question relates to dilution effects. Can you repeat the question, please? So
Yeah, I mean, the plume must assume a certain volume in order to be able to assess dispersion. So what volume does the model assume? Yeah, the discharge volume in order to be able to predicate whatever the dispersion's going to be. Is
yes.
it?
In the model, we release the wastewater in a roughly 5 kilometer square centered at the Pilgrim Nuclear Power Station.
But at what volume? I understand it. I mean, a volume of 1 gallon released from Pilgrim Station versus a volume of 1 million gallons would disperse much differently.
It would not disperse differently in terms of transport pathways. It would lead to different concentration, but that's not in the maps that I showed. The maps show transport pathways and the associated time scale for those pathways. And it would be the same whether you release 1 gallon or 1 million gallons in that domain.
Okay, thank you. And Dr. Buessler, are you aware that the Pilgrim plant does have an environmental monitoring program that reports out on sediment sampling, shellfish sampling, finfish sampling, crustacean modeling, that modeling does exist? That's done as part of the environmental monitoring for effluent release from the plant?
I have to say I'm not up on every report.
Okay.
Often what I saw in some of the reports from, say, 3 years ago were pretty high detection limits and mostly focused on single isotopes like tritium, and everything else was at a much higher level in terms of detection. The lower limit of detection was quite high. So it was basically when there's a no detect, that doesn't tell me anything as a scientist of what was released, because we know these isotopes are in that release water at some level. So I'm looking from the lowest levels up. Those reports are often looking from the high level down.
Okay, thank you. And I do think that the information that you provided as part of the SONGS analysis, I think it is very important. I understand that we're not talking about an enclosed bay, but my understanding of the California coastline, because they're seeing the radiation effects from Fukushima Daiichi on the shoreline, that it's predominantly moving back from that 1 mile discharge piping toward the shoreline. In that SONGS evaluation in 2020, and again, San Onofre had been a shutdown plant since 2013. And in that interview, you said that the 2019 release levels in San Onofre, which was 1.26 e to the minus 6 microcuries per milliliter of cesium, did not provide you with a level of concern, since you could swim in the water for 100 years and receive 1/10 of the dose of a single dental x-ray. You said ingestion would be 5,000 times lower than the World Health Organization drinking water standard, and you didn't expect accumulation in seafood or the seafloor to lead to any health effects in human beings.
Right, what we're saying here is similar. All I've seen are numbers. These numbers are much higher than I think what you just quoted, 10 to the minus 2.
And they are.
Milliliter.
If we were to look back to the 2015 data that the NRC has published, you'd see comparable cesium levels in a Pilgrim treated discharge to what was produced at San Onofre. We'd also be happy to share the information on cesium concentrations in treated water with you, if that would help in your assessment to be able to provide more detailed information.
Thank you. I mean, what we've often said is, to my mind, you would treat the water. It's been, what, a year and a half since that report? And I don't think there's been any treatment. So the levels, maybe you can confirm for me, are the same today, except maybe for evaporation that releases tritium but would concentrate the other isotopes. So I don't think the situation has changed.
No,
today
they
over
have
what
not changed,
is
but
in-
they will change through treatment to numbers that were representative of the 2015 releases, because that is the treatment system. That's the capability of the treatment system to reduce the concentration of that isotope by that factor. Thank you.
I think I have a question for Irina. Just to understand, is she still here? Is she still with us?
Yep, we'll get back. There she is.
You still, good, thank you. I'm still trying to understand your graphs with the maps and stuff. You said that you measured the wind every 6 hours for 3 years. Or was it the tides?
It's not the winds. We have simulations of oceanic currents, and we know them every 6 hours for 3 years.
For 3 years. And so did the graphs reflect an average of that?
Yeah.
So
the graph reflected, it's a statistical map showing most probable pathways. So it's averaged over the same season of the 3 years.
So you averaged it by seasons?
Yes. That's why I had the 4 sub-panels, right? Subplots in my maps. Those correspond to different seasons.
Thank you. And you said it was surface. So how deep would you call the surface?
A few meters.
Sorry?
2 meters.
2 meters.
Roughly 2 meters. Yes. This is what the transport would look like within the 2 meters, 2 upper meters of the ocean.
But the first graph where you have the currents coming down from the Gulf of Maine in 3 patterns, that looked to me like the map from Deer Island or something. You know, the discharge from there that comes into Cape Cod Bay. Is that where that map came from? Because it sure looks familiar to
Are
me.
you referring to slide 13, Pine?
Slide 13.
Yeah, that one.
Is up.
Yes, so this map, yes, this map actually came from analysis of drifting buoys over 20 years. So again, this is how the mean currents, time averaged picture of mean currents within this area, and it's based on analysis of drifters or drifting buoys.
So in terms of a study for something like this to set a standard for decommissioning, because I think that's your question, right? Your final question was, are we allowing something that we shouldn't allow? Are we going to put together something like the impact of Deer Island on Cape Cod Bay that might be causing that, you know, that deoxygenating bloom that we have in the summertime, with something like this, which is relatively de minimis? So these guys are not going to discharge at the surface. They'll discharge theoretically with the tides and the current and the high tides. So it will be diluted. So I'm trying to understand how we're going to take this study and help figure out what the answer is. Or do we need more study in order to help figure out what the answer is?
Do you want to answer that, Irina? I mean, I think what she's saying here, this 3D, is about getting some more depth information. You could do that.
Yeah, because we have stuff coming into us all the
You could
time.
get higher resolution data.
Yeah.
So instead of being a 5 by 5 kilometer box, it can be half a kilometer by half a kilometer. There are things you can do to improve, but the general conclusions probably won't change.
Well, but But so if what we're using is a surface and we're discharging below the surface, and we're discharging diluted plume rather than a concentrated plume of a gallon of dirt, doesn't all of that have to go into the understanding of what would be the best course of action?
The temperature would matter, the salinity would matter, the depth, but the mixed layer, Irina, I don't know what your average mixed layer depth at that point is, probably much deeper than 2 meters. So her model probably represents a deeper slice than just a surface 6 feet.
Yeah, I
because
love
the ocean mixes
I love the
down.
wind. I love knowing what the depth is, and I love the tidal action because I think it's really important in terms of the bay. So we have when
This
you know,
includes tidal
when the
action.
tide is leaving and the wind is blowing that way, all is good, you know.
This
If we know
considers
how long that can
tides.
be sustained and they know when to release it at the tide.
Yeah, this considers tides and seasonality of winds,
Yeah.
and just a different resolution could be
Yeah,
done.
that's really all. And the other thing is, did you write all that down somewhere so I can read it again? Is that a
Yes.
written report yet, Irina?
Yeah, we submitted a paper that has been accepted. It should come out. It's a peer-reviewed paper in Journal of Physical Oceanography. It should come out very soon.
Oh, great. Can you send it to us when it, thank you. Thank you very
We were
much.
hoping it
I
would
really
be out.
appreciate your work. Thank you.
It's the peer review process, and it's past peer review, so it is accepted, but she can't share it until that comes out. Kevin? What's the title of your paper, Irina, that's coming out? I can't remember.
It's one
Something
second.
similar to the,
Model. So the title is Model-Based Study of Near-Surface Transport in and Around Cape Cod Bay, its Seasonal Variability and Response to Wind.
you thought it'd be longer.
Is this model purely for the discharge of liquid, not for evaporated water?
Yeah,
So do you have any modeling for evaporation, forced or natural?
this is not an atmospheric model.
Okay.
It does not have transport,
And
winds and things.
would any part of this model be useful in assessing the effects of evaporated water?
No, unless there's, deposition through rain back in the ocean.
Sure.
This type of model would be very relevant to that.
But the
So that'd be
point
a
of entry
combined
into...
model, but
right,
that's not what Irina.
Okay. And the point of entry into the water would be presumably variable by where the rain falls, right?
Right, that would be.
So, okay. Is there any way to model forced evaporation and the effects of that in the bay or in the ocean off of Massachusetts more broadly?
I mean, I'm not an atmospheric transport modeler, so I don't think I even want to get there, but you'd have to include the precipitation as well.
Okay.
Wet and dry deposition. that
Okay.
type of thing.
But we would have to get that from, if
Another
it does exist, we'd have to get that from another source.
There must be models like that.
Okay, thank you, appreciate it.
And wouldn't the sea breeze effect be very relevant?
Any other questions from the panel?
Yeah, Mr. Chair. Oh, go ahead.
Yeah, we'll get to those. Andrew?
More comment than a question. I'm at a little bit of a loss of what we just spent the last hour plus talking about. It's like some bizarro parallel universe in which this proposed discharge is actually considered legal by the Commonwealth of Massachusetts. The world I live in, this whole activity was told by the Commonwealth that it was not in compliance with the Ocean Sanctuaries Act. The Ocean Sanctuaries Act wasn't predicated on radioactive discharge. And so while this is a very interesting, very informative conversation about how things move in the bay, in terms of the things that are before this panel, I don't get what we're spending any more time on this for.
Anything else? I had two very quick questions. If you could put up slide 10 for a moment, please. One just before. Looking at those two, is it my understanding is that Stellwagen Bank lies roughly to the north of a line headed west off the top of Provincetown. Is that roughly it? So I guess the question I'm really asking, do I correctly understand from these that the discharge, according to your studies, there is a high probability that at least some of it will flow into Stellwagen Bank?
Yes, but the colors over, you're correct in pointing to the area of the Stellwagen Bank, and we do see it's not white, especially in spring and summer. So yes, some of this water will be flowing over the Stellwagen Bank, but the colors over the Stellwagen Bank mostly are not yellow, but green and blue. So this is smaller probabilities. Most of this water would go through the channel between Provincetown and the Stellwagen Bank.
But particularly in the fall, I see what looks like more in Stellwagen Bank than in the other three seasons. And I guess my other basic question, and I graduate generalizing a tremendous amount of work, what I'm seeing in that top row is that the probability of it flow along the west coast of Cape Cod Bay is quite high throughout the year, and that the variability is more on the east and the southeast side. Is that fair?
Yes, that is fair.
Okay. And then on the next slide, just one really very quick question. I initially thought that dot was Pilgrim Station. I gather it is not. Is that
No,
basically a buoy out there somewhere?
So this is wind conditions, and the winds. So I think this relates a little bit to the question I was asked before. How did we produce these maps? So we took a point in the middle of the bay, and we have wind speed and direction every 6 hours for 3 years. So we averaged all of those winds for 3 winters, 3 springs, 3 summers, and 3 falls. And that's what is shown in these diagrams.
And I guess the question I'm really asking, I may have been asked before, was there some type of buoy out there that basically took those readings?
Yes, so the model uses realistic atmospheric forcing that comes from, it's called NAM, North Atlantic Modeling Forecasts for Winds. That's the forcing in the model that's applied to the ocean, and then the model produces currents in the ocean. I'm not sure if these details really answer your questions.
Fine.
But the winds, the forecast model for the winds does have information from the buoys.
Well, I want to thank you both for coming. One thing, basically, I'd like to let you all go now. Are there members of the public that have specific factual questions? I want nothing else, but I do want specific, if you have a specific factual question and not a speech or any type, I think this is the only time we're going to have to ask them, because I want them to be able to go home. Mr. Campbell?
Okay, my first question would be...
How many do you have?
My name is Brian...
Would you get up to the mic, and how many do you have? Because this has to be quick. We're running
My
way
name
over
is
time.
Brian Campbell. Back in 2023, Woods Hole Oceanographic Institute was awarded a Sea Grant to shed lights on...
What's the question, please?
My question is, was the money for that Sea Grant from NOAA part of this study?
Rapina, I think you said, yes. She said earlier this was Sea Grant.
Yes.
Another specific question? Yes, sir.
My question is...
Mike, please.
So I've heard a fair amount of discussion about the water having been cleaned or not having been cleaned, filtered, et cetera. In what way, I know it's been cleaned of particulate matter, but in what way or in any way has the wastewater been actually rid of radioisotopes? Ken mentioned briefly that it would be easy to do cesium. Have we actually tried to do that?
Well, actually, that's part, we don't need Ken to answer that question. That's a question, and then we get into what is the treatment, and that we'll save for Mr. Noyes later. I'm trying to let Dr. Buessler go. There were one or two other questions?
Susan, I'm going to let you talk. You're unmuted.
No, she's not. You're still muted.
It's unmuted.
Okay.
You're talking, you go ahead. Yeah, I can't
Okay.
move it.
Okay.
Just unmute. Did you unmute your own computer? Because she's allowed to talk.
No, she has a specific question. This is the only time we're going to get answers.
She's allowed to talk. That's fine.
Yes. If we can get the mic open. Okay, was there someone else?
Yeah, there's Richard Boston.
Okay. Susan, what's your quick question?
Hello, can you hear me?
Richard, let me get to Susan first. You just hold. Susan,
Okay, thank
you're
you.
unmuted.
I would like to know why it is you don't believe scientific evidence. Are you planning on continuing this discussion into next year, or are you just trying to attack science? I'm
To whom
not
is this question directed?
Um,
Is this directed to
I
the
don't
panel
know
or
who
to
to
the
ask.
doctor?
Should I ask Holtec? Should I ask
No,
NDPAP?
at the moment, I would like specific factual questions to Dr. Buessler so he can give the answers to those before we let him go home.
All right, I'm sorry. I'll withdraw my question.
Fine, I'm perfectly happy to hear from you later. I just want to let him go home. Richard?
Hello, can you hear me?
Yes.
Thank you. My understanding is from Arena is that the models considered the transport of the effluent release in the first few meters. So that being the case, the windroses make sense to me in terms of the transport and dispersion. I'm not an oceanographer. I'm a retired CCM certified consulting meteorologist for the record.
So what's the question, Richard?
Anyways, the windrows made sense because if the model's assuming...
Richard, what is your question, please?
I'm leading into that right now. So I understand why the results turned out the way they were in the summer and spring and summer as opposed to the fall and winter there. But I recall from years past on the Nuclear Matters Committee and also serving on the ENDICAP, I believe I'd seen some presentations of people who were of an
Could you get to your
oceanography
question,
bent,
please?
that
We're
Cape
running
Cod
way
Bay
over
would
time.
flush itself out fairly quickly and not be a matter of weeks, but maybe days or less, depending on the exact volume of water you're talking about. So I guess I was a little surprised just to see the results, but the model's the model there. But again, reflecting on Pine's comments and questions, it'd be interesting to see a little more sophisticated modeling, factoring those things in the future. Thank you.
Well, I think we're there.
No, there are two
Oh,
people.
excuse me, right, very quick, because we're really running over time.
Ken, thank you. I just want to ask Ken, he had mentioned there was 950 terabecquerels of cesium-137 from the nuclear weapons. And so have you or Woods Hole in general tried to determine like that man-made background? You know, in other words, away from the influence of Pilgrim Nuclear. Do you have a rough ballpark estimate of that kind of number? The concentration of cesium-137.
Yeah, we know the level in the ocean quite well, and it doesn't vary. This typical surface ocean would hold for Cape Cod Bay, would hold for further out in the Atlantic, 0.002 becquerel per liter would be the number in the ocean.
Okay. Diane?
Thank you for coming. Just to wrap up, did you make the recommendation that one of the options should be is to hold this water until the tritium decays? That could happen in 24 years or whatever. Was that one of your options as a solution to this situation?
I said there are several options, and one, if you could remove things that are easy to remove, that probably should be done no matter what. And if your concern is tritium, the question is, do you release it today? Do you hold it on site? What do you do with it? The point being that materials can be held on that site that's highly radioactive for decades, centuries. I don't know how long it will take. 1 million gallons is about a Olympic-sized swimming pool. It's the size of something like this room that could also be held either in liquid form or in a solid form. And after 60 years, basically less than 3% would be left, because every 12 years it would go down. I know there's a cost, there's a consequence, there's risk about citing things, but that is an option.
Okay. Anything else? Okay, and thank you very, very much. And Irina, many, many thanks to you also. I think this is something we've all been waiting to learn more about.
My pleasure.
Dave? It liked you an hour ago. It did. Is there any other way to get this to you? This came up. 6 o'clock. He was working on it a little before, so we had this done. Seth? Seth, can you present yours while he's playing with that?
I can, but one of my topics
about your phone? He's got it. Good. Blow it up. Hopefully it'll just blow. Full screen. Okay. Hopefully we're there. Victory is mine.
All right, I apologize for the delay. This is the Holtec update. I'll try and walk through these slides fairly quickly. So the first slide is the waterfall with the sequential schedule activities. Worth pointing out on this slide is under characterization and the license termination planning. We did complete a round of groundwater monitoring well sampling that was conducted between November 18th and the 21st. That's part of the Massachusetts Contingency Plan Phase 2 of the comprehensive site assessment to attempt to locate the sources and come up with the future plans for the low levels of non-nuclear or non-radiological effluents that were seen in the previous groundwater sampling. Also, with respect to the ISFAC, we have completed the activities under the order of conditions for the haul path that was used to move the dry cast storage from the industrial area of the plant up to the ISFAC. And we will be submitting this month for closing out those order of conditions with the town's Conservation Commission. The rest of the individual slides, so the individual swim lanes, will be covered on their own slides. So under demolition and ongoing activity, 2 months ago we talked about removal of the augmented off-gas system charcoal absorbers. These were 19-foot tanks that had a radiological component. They also had asbestos component associated with the tanks. They were removed. All 12 of the vessels were removed, and they have been shipped for radiological disposal in Andrews, Texas. In addition to that, we continue with removal of the prompt alert notification system sirens, with 33 of 113 sirens removed, scheduled to complete in the first quarter of 2025. So for demolition status, this picture has not changed since what we saw 2 months ago. The small, lighter yellow block that is in the middle left is the augmented off-gas building. We continue with removal of the vessels are removed, continue with removal of the piping, and ultimately we'll get into demolition of that augmented off-gas building. For reactor vessel internal segmentation, the internal segmentation work is complete. We are in the process of removing equipment from the dryer separator pit and the reactor cavity. That was the equipment that was required to support the segmentation activities. And then once all that material is removed, we'll be ready to drain the reactor cavity and dryer separator pit to the torus. For regulatory update, we did receive our third quarter 2024 inspection report, documenting 2 on-site weeks by the NRC, a week in July, 1 in September. The results were no violations of more than minor safety significance. We did submit our NEPDES and surface water discharge permit renewal applications. That's the 5-year renewal of the 2020 permit. and we reported a septic system overflow. This was less than 50 gallons that occurred on the 11th of November. We had a mechanical issue with one of the pumping stations on the site that resulted in less than 50 gallons making it to the storm sewer. There was no indication of any odor or any flow at the outfall into the intake canal, but we did report it to Mass DEP, EPA, the Plymouth Board of Health, and the Nuclear Regulatory Commission.
Dave, could you send the renewal application to the panel?
I think I can.
Yep, I'm sure it's a public document. That's the easiest way for us to get it.
For on-site water volume update, I'll give you an update as of 11:15. 916,442 gallons approximately remain on site. The heaters in the spent fuel pool were energized on the 4th of November, and that's for building and refueling floor heating. It's successful so far in maintaining the temperature on the refuel floor at approximately 65 degrees and maintaining temperatures well above freezing in the quadrant portions of the reactor building. For site source term reduction, we continue to transport for disposal the majority of the Class A waste that is being generated and some of the Class B waste. In 2024 to date, just over 33,000 cubic feet with 71 curies of activity, bringing our total for the project to 250,000 cubic feet and just under 2,000 curies of activity shipped. And that ends the report, pending questions.
Any questions?
Hey, Dave. So the reactor building and turbine building, those activities as far as demolition aren't projected to be started until 2032, correct?
2033 through 2036.
So what are the critical path activities that you see between now and actual demolition of those buildings?
Characterization of the site, submission of the license termination plan, and continued removal of the internal components within those buildings.
Okay, thank you.
I have just one question, Dave. Your volume of water is 916,000 gallons. Is it fair to say that the decrease to that from what you reported when we were last here is essentially all natural evaporation? I noticed you didn't start the heaters until a few days later.
Yeah, I think that's fair to say. Yeah, a very small percentage of that overall difference is due to any heating.
Thank you. Any other questions? Thank you.
What is that container on that big truck you got in that picture?
I'm sorry?
In I think it's the last, slide 8, the last slide.
Yes.
What is the container?
What is it containing?
What is that container?
Oh, it's an impact limiter on a type B storage cask. So specifically, this is an overpack, and inside of the overpack is rad material that is inside its own canister, but that's an overpack for shipment.
Is that a single truck or is that?
Yes, yeah, it's
Holy
it's a single truck with a flatbed, with a flat surface.
Going to?
WCS in Andrews, Texas.
Wow. Thank you.
And does that go all the way by truck?
Huh?
This one did, yes.
Thank you.
Yep.
May I ask you a question?
Sure.
At the last meeting, you said if you were to ship the water, that the option for a train would require driving a truck to a train in Pennsylvania?
Yes.
I was wondering why you couldn't use the train, which appears to be closer, that Vermont used? Another shoot up to Vermont as,
To use the one that's physically part of their facility?
to use the train that
Right.
Vermont used.
We
It seemed a lot closer.
We need a facility to be able to transport it. We may be able to transport it on the Vermont property, but the closest place, the closest facility that's licensed to be able to transport liquid is in Pennsylvania, short of using the one that's at the Vermont facility. And we'd have to figure out liability for any water that we would truck to Vermont.
Are you
and then-
looking to do that, or you just are not interested in shipping?
No, we would look at any option.
I'd be interested for a report back.
Okay.
Great, thank you.
Seth?
Mr. Chairman, my update for today starts with some information we received from Holtec a couple of weeks ago. So
Your turn.
May I proceed?
Of course.
Okay, so Mass DEP received an email from Holtec on November 8th informing the department that it was planning a pilot test using a barrel evaporator to evaporate water containing a solution of sodium pentaborate. The company stated that its plan involves evaporating 55 gallons of sodium pentaborate solution, and if successful, Holtec would seek to evaporate a total of 4,000 gallons of the solution containing sodium pentaborate. The 4,000 gallons of wastewater containing sodium pentaborate is not part of the approximately 900,000 gallons of wastewater in the spent fuel pool, reactor cavity, dryer separator pit, or torus, components of the reactor system. So Mass DEP has requested that Holtec not proceed with the 55-gallon test evaporation at this time. The department's in the process of preparing questions regarding Holtec's evaporation proposal in regard to air quality and waste treatment and/or disposal in accordance with Mass DEP regulations, so applicability. So Mass DEP will be evaluating whether state regulations may apply. The permit modification, as Dave indicated and as previously reported, Mass DEP issued a final determination to deny Holtec's application for a wastewater discharge permit modification. Holtec has appealed this determination to the Mass DEP Office of Appeals Dispute Resolution, OADR, which has issued an initial scheduling order. OADR is also considering several petitions by outside parties to intervene in the proceedings, and I believe that has been finalized.
Basically, in terms of who are now the parties that have intervened, yes, that was finalized probably the better part of a month ago.
Okay.
So there are now, I believe, 4 interveners who are parties in addition to Holtec and DEP.
Okay.
It's actually HDI, to be precise.
Yep. And as I stated last meeting, because of the pending appeal, DEP is unable to meet with members of the public or discuss any issues that could implicate ongoing legal proceedings. Dave also mentioned that the Mass DEP surface water discharge permit 5-year renewal has been submitted to Mass DEP, and that was on November 15th. On site assessment work, the Attorney General's office is working to finalize the state's response to Holtec's site assessment work plan. Can't speak of the timing for the AGO's review, Mr. Lampert. Response actions under the Massachusetts Contingency Plan, MCP, or 21E are ongoing in response to notifications of PCBs, metals, and PFAS detections in 2022. The Phase 2 comprehensive site assessment, which documents the nature and extent of contamination and contains a risk characterization is due to be submitted by April 21st, 2025. As far as any other cleanup issues, there's no update from Mass DEP on additional cleanup activities. The DEP continues to work with the site on demolition activity and asbestos requirements, and we meet regularly with the company as they move forward with different abatement and disposal issues as far as asbestos. And we're still continuing to evaluate Holtec's request to change its wastewater disposal system to a Title V system. Dave, is that on us at this point?
Yeah, we've just recently provided the 5-year data that Mr. Gould requested, so he and I need to work together and come up with a schedule.
Okay. A couple of new items from MEMA. MEMA's Eastern Regional Office is continuing to work with the former EPZ communities on comprehensive emergency and continuity planning. And MEMA's Logistics Division has recently taken possession of 3 portable meters from the former Bridgewater Reception Center. The meters are now staged at the state's logistics warehouse.
I assume they're not plugged in.
I'm sorry?
I assume they're not operating.
I can't answer that.
Is that a fair assumption?
Yeah, I don't know.
They were
The
they were in
meters
storage.
at present are just in storage. They are operational though.
Okay, that's the end of my report.
Okay. I just had one question for either you or Dave. What is that sodium, whatever it is? It's not part of the 1.1 or how many million. What is it?
Sodium pentaborate was a solution of concentrated boron that when the plant was operating, it was an emergency safety system to shut down the reactor in the event that the control rods didn't work to shut down the reactor. So it was a backup emergency system.
So at this stage, is it basically chemical waste?
Yes.
We're going to ask them to take a look at it, and then we'll see where we are.
Any other questions?
All set?
Thank you very much.
Thank you.
Public comment. How many people want to speak? 1, 2, 3, 4, 5, 6. Okay. We normally have 30 minutes. If you can keep it shorter than that total period, I think we'd all appreciate, given we're about half an hour behind time, but I'm not going to cut you off. I'm looking at the whole 30 minutes. If anybody runs over about 4 minutes, I'm going to tell them. No, they get 30 total. If somebody goes 6 and somebody goes 4, that's fine. Okay? Yes, sir.
I'm going to be really quick. My name is Chris Nord. I live up in Amesbury, Massachusetts, and I'd like to direct a question to the Vice President here for Holtec, Mr. Moylan. Am I getting your name correct? Right here, the Vice President? Okay. My question to you is, my understanding is that a contractor hired by the previous owners of Pilgrim assessed that 60% of any airborne effluent would fall into the coastal waters off of Massachusetts. So my first question to you is, do you accept that that's roughly accurate?
I'm not aware of this contractor or the study. If you have a copy of it, I'd like to see it.
I thought it was common knowledge. Does anyone know this gentleman's name? I mean, I read this. I know it's part of the public record. I just don't know the gentleman's name. He was hired by the previous owners of Pilgrim while they were still operating. Anyway, I could get that documentation to you, but I believe that that was a scientific assessment that 60% of airborne effluents from the Pilgrim plant would end up in the coastal waters of Massachusetts. Given that that may be true, what is your company's rationale or justification for allowing the continuing forced evaporation of radioactive wastewater when you know that 60% of that wastewater is going to fall back into Cape Cod Bay in violation of the Massachusetts Ocean Sanctuaries Act? That's my question.
So first off,
I was asking the Vice President, I wasn't asking you.
And Dave can speak also.
so first off, we don't believe that it's in violation of the Ocean Sanctuaries Act. Second, the reason why it's okay to continue to discharge the evaporative effluent is that it's something that is highly regulated by the NRC. It's monitored for its impact on the environment, and it's assessed both at its point of release and at the impact on the environment.
How can you say that it's not a violation of the Ocean I don't understand how it cannot be a violation of the Ocean Sanctuaries Act, given that 60% of whatever you release to the air falls back into coastal waters of Massachusetts. How can you assess that that is not a violation? I don't understand that. I mean, do you have a scientific rationale behind that?
It's not a scientific rationale, it's a legal rationale.
It's a legal rationale.
Yes.
And is that legal rationale simply that because it's being released to the air, it's not a violation?
That the Ocean Sanctuaries Act does not apply to the gaseous effluent that's being released from the reactor building vent at Pilgrim.
Even though it's going to fall, even though the majority of it will end up falling into coastal waters off of Massachusetts.
The study, let me just say, was done by Dr. Kevin Okula from Harvard, from Entergy. Entergy paid for it.
Right.
I have copies of it.
Okay.
And also Dr. Bruce Egan, because I was involved in that 6-year litigation. Dr. Bruce Egan did the sea breeze effect.
I mean,
So
I'll
both
just
are
finish by
important.
saying, I think that this is an ethical and a moral choice that your corporation is making, and you're making yourself enemies of the people of the state of Massachusetts by continuing this action. Thank you.
May I add one thing? I'll add that if we go through the minutes of this year, that Dave Noy said that the company supported Dr. Kevin Okula's study. And I'll find that.
I've never even seen Dr. Okula's study.
Well, I'll find it for you. And so you just change your mind. You know?
Dr. Potvin.
Yes, Barry Potvin, the Chair of the Plymouth Board of Health. Just a couple of follow-up questions for Dave. Can you tell us how the 90-degree temperature was decided upon for the submersible heaters?
How the 90-degree temperature?
They are set for 90 degrees Fahrenheit, correct?
No, they're set to maintain the temperature at less than 125 degrees by design.
And what is the rationale for that?
The
particular
rationale
amount?
was that that was the temperature to which the spent fuel pool and reactor cavity were generally maintained during refueling activities during the 40 years of plant operation.
So how does that pertain to what's happening now during the decommissioning and demolition?
It's just within the experience base of the plant, and we understood exactly what the impacts on effluents would be.
Okay, and it is maintaining the internal temperature where the workers are, I think you stated 65 degrees?
65 degrees on the refuel floor.
And what was it before you turned the heaters on?
It depended on the day, but probably 55 to 60 degrees.
So it hasn't made a huge difference
Well,
so far?
it's significant. I mean, the days have gotten colder.
Yeah.
And the temperature would have gotten colder too.
Okay, well, I don't want to take a lot of time because I know it's late. I just wanted to state again that when we start looking at what NRC allows or what any federal or state agency allows in terms of maximum contaminant limits, MCLs, that means that that's allowed. It does not mean that it is safe or without any risk. Thank you.
My name is Brian Campbell, retired electrical engineer, and I believe the chairman knows me because last September I tried to speak on Zoom, and I was censored. I
Actually,
strongly support
that's
discharging
not quite
treated water
fair,
from Pilgrim Nuclear Station into Cape Cod Bay. Holtec is safely decommissioning Indian Point Nuclear in New York. Generation Atomic calculates that the water outside the plant, if one was to hypothetically consume it, it would have to drink about 80 gallons of this, it's brackish water, and it would be equal to the radiation in a single banana. This is about the same for Pilgrim. The presentations by Holtec to this panel shows Holtec to be a good corporate citizen performing the Pilgrim decommissioning in a truthful and open manner that should be commended. Microsoft AI Copilot calculates that 12 curies of tritium in the million gallons, I guess about 900,000 now, has a mass of 1.24 milligrams. The fear-mongering is delaying the 2027 completion and speedy return of 1,600 acres of prime oceanfront property to the tax rolls of Plymouth, which was the goal for the Pilgrim decom. And again, Chairman, about Canal Number 3. Officials gathered to mark the completion of Canal Number 3 back in 2019 in September. A gas and oil-burning peaking electrical generator. State Representative Randy Hunt said a completely renewable energy is the goal of the state. It's ironic that we had to build a fossil fuel plant to make our renewable energy grid more robust. The new unit helps to fill the gaps in those systems and has become more vital as Plymouth nuclear plant has been shuttered in May of 2019. Officials bragged about all the new tax revenue going to Sandwich coffers. And in Plymouth here, we lost around 500 union jobs. And that's what happened with Pilgrim. Never mind the tax base that was going to Plymouth. AI Gemini informed me about radon remediation in flue gases from gas peakers. No, these methods do not collect all the radon from the flue gas. While they may significantly reduce radon emissions, some radon will still be present in the gas after scrubbing. This radon is a lot more radiation than what would ever go in from 1.2 milligrams of tritium going into Cape Cod Bay. AI Gemini informed me Microsoft signed a 20-year power purchase agreement with Constellation Energy to restart 3 Mile Unit 1 nuclear reactor. This reactor will supply carbon-free energy to power Microsoft's data centers. So if Massachusetts continues to delay decom, perhaps Amazon or another company will come in here, or maybe Commonwealth Fusion. They need to build their arc someplace, which is their fusion
You're at 4
reactor.
minutes, Brian.
Okay,
AI may have,
my turn.
okay, you get the picture.
Thank you. Thank you, Brian. Hi, I'm Rosemary. I am Rosemary Shields with the League of Women Voters, and I'm not going to ask Holtec anything about they're being sued by Adam Snyder, who was working at Holtec, and he's suing them because of radiation poisoning, that he was assured that he didn't have to wear protective gear or use a ventilator. And I know that Holtec can't talk about anything that they're being sued for, so I'm not going to ask that. But I want to ask, I would like to ask what Holtec does for monitoring radiation contamination for their workers.
So we have proceduralized controls. Any worker that is going to work in the radiologically controlled area maintains a dosimeter of legal record. If they are performing activities in elevated radiation fields, they also have electronic dosimeters to track the amount of radiation they receive for them to be able to see that on the spot. We also, in accordance with rigorous procedures, have requirements for respiratory protection in areas where individuals might be subject to airborne contamination, and assessments for those workers in those environments as well.
Well, I'm really glad to hear that all of that is being done, and, good luck with Adam Snyder and the guy who lost part of his tongue and his esophagus while working in your plant. Thanks.
Hi, Diane Turco with Cape Down Windows. I just wanted to follow up with that is the whistleblower letter that I received over a year and a half ago, and nothing has been done or followed up on with those allegations by anybody, the state, no one. But that the radiation protection team in your own building was critical of the submersion heaters in the water. So I just wanted to remind Holtec, when Senator Ed Markey came on in May of 2022, Chris Singh told Senator Markey, quote, "But we would not discharge it until we have consent from our stakeholders," unquote. The state has already said it's illegal. It's illegal to dump. And yet you're appealing that decision by the state. That's another sign we don't trust Holtec. When Holtec was dumping the water at Oyster Creek in New Jersey, they wanted to dump right into Barnegat Bay, but there was also questions about evaporation, and Holtec refused to do the evaporation. Quote, "Evaporation releases higher levels of radioactive materials due to the concentration and lack of dilution when the water becomes a gas." That was Holtec Representative Joseph Del Mar. Does Holtec still hold that position?
That was in reference to large-scale evaporation where water temperature is raised above the boiling point and radionuclides can then become vaporized and become airborne. That is not the scale of the heating or the evaporation that's occurring at Pilgrim.
Are radioactive materials becoming airborne at Pilgrim?
Tritium. From the heating of water, tritium is the only one.
Radioactive materials are being released into our environment from the
It
evaporation.
happens all the time anyway,
From the
Diane.
forced evaporation.
It's an open pool of water. It evaporates.
We understand that, but you're forcing it. It's because you can't dump it. So we're not dumb. We know what you're doing. You're not heating the building for work or comfort. You're trying to get rid of that water.
If we were attempting to evaporate the water, we have picked pretty much the worst system that you could do in order to be able to do that.
Well, that's nothing new for Holtec. So the community is asking you to stop the forced evaporation, stop poisoning our community.
Well, who are we tonight?
I didn't look up any hockey players, so we're going to stick with Jacob Andrews as usual. Once again, we've got, I'm going to butcher the name, Busler, the doctor. Buessler. Thank you.
Buessler.
If you're having reports come in like this, it would be greatly useful for the public if we received, I'm going to call it a key, but I know that's not the right term, so an idiot chart of breakdown of terms used for measurements. Because going from curies to becquerels does not make sense to the average viewer and does not help anyone other than regular scaremonger or fear mongering that you guys put up.
That is actually a pretty darn good idea. Why don't I have a conversation with Dave and let's see if we can come up with. You can tie these all together, as we say, typically. Probably Curies is the one that the public is most familiar with.
Curies is the most commonly used.
If we could tie all this to Curies so people had a conversion chart in front of them, I agree with you, that would be useful.
Because when you put up a number that says I think it was 7 to the
E to the minus something.
e to the minus 3, which is 1 decimal point less than what it was actively used. Doesn't help when you turn around and tell me that that same actively, the spent fuel rod pool is filled with sea life for boost. What was it called? What was the other? Becquerels. Means nothing. It's just a bigger number.
Yeah, and same way that when we're talking about radionuclides, we need to talk curies and not micrograms.
So we're still talking about
Same
doses
thing.
less than you get on a plane.
Hi, my name is Pat Watson. The last person spoke. I think it was a very good point. Oh, I'm sorry. Was somebody next?
Go ahead, speak.
Oh, okay. You sit down, didn't know. Anyways, that having a key or a information ahead of time to understand, or some common language, I think it's a great idea. But to say that something that you don't understand, like I didn't understand, to call it fear-mongering is inaccurate. You should never call something fear-mongering if you don't understand it. Understand it first, and then call it fear-mongering. That's my only point.
Hello
We're
again,
running
Peter
close to
Peter
time.
Moyer.
Okay, please.
Yep, I'll be quick.
Oh, no, I've noticed more people than I thought we
Yeah, I know.
had.
I got it. I have two questions, actually, for Holter. One of which is the question I posed before. That is, I've read literature about it. It talks about cleaning the radioactive, the radionuclides. It talks about filtering them, et cetera. And then I noticed that the values of the radionuclides were pretty much exactly the same in 23 and 24. And I'm wondering, do you do anything other than cleaning the gross particles out of it? And for instance, Dr. Booster mentioned that it'd be easy to peel off the cesium. Do you do that?
At the present time, we do not. We do run a important portion of the water through the fuel pool demineralizer that does provide some demineralization function, but the water would be treated prior to a potential discharge in the future. And that would be done through demineralization and carbon filtration.
It's not done currently before you evaporate the water?
No, it's not.
So it's untreated water, really, to date?
Other than the removal of the
Particles.
particulates.
Yes, I understand.
Yes.
But that's what it is, because it's very confusing. People read cleaned, filtered, but you're basically saying, other than the particulate matter, it's not cleaned.
That's correct.
That's right.
Keep
Okay,
in
my
mind,
other question-
just at the temperatures that we're talking about, that the material is not getting, other than tritium, the material is not getting carried over with any evaporate.
Well, that's my second question, because I think you're obligated by the NRC to give them readings from what radionuclides come out of the vent, out of the stack. And I've never heard them, but I've read in the past, people talked about cesium, they talked about radioactive iodine. This is back in the 80s. And I'm wondering how often you do measure that? Do you report it publicly? Can we see it? What comes out of the stack?
Yeah, we record it monthly, and that information is reported to the NRC annually. So on the NRC's webpage are annual reports, the RAD effluent release reports that provide all of that data.
And you're saying just tritium shows up, no cesium doesn't show up at all?
No, that tritium is not the only thing that shows up, because there are activities on the refuel floor that are creating airborne separate from the evaporation of water.
But coming out of the stack and going into the air, now you're saying it's not just tritium, it's other stuff.
That's correct, because we're performing physical work that generates those isotopes.
But, so in other words, the stack does release other stuff, for whatever the source, into the atmosphere, yes?
Yes, in minute quantities, yes.
Dave, am I right that those reports are submitted in roughly March for the previous year, just so people have a handle on it?
Yes, that's right.
And Dave, doesn't technetium-99 become volatile at 95 degrees?
I don't know that I've ever seen whatever that isotope, technicum or technetium or whatever it is, I don't know that I've ever seen that in our gaseous effluent.
No, I was told by Marco Caltafin that at 95 degrees, that was one of many that become volatile.
But it would have to be there, right? I mean,
Oh, obviously.
Joanne Corrigan. I don't know if some of you on the panel are aware that there's a very large credibility gap between some of you on the panel and the general public. And I think it's very disingenuous if Kyle, or whatever his name is today, he didn't give it any name, if he really is Mary, not you, Mary, the other Mary's son, why isn't he giving his first name and last name like everyone else does? And I think it's disingenuous if he is your son that he doesn't say his last name. So at least now we know his last name and he can use Kyle or Cher or whatever he wants for his first name. Thank you.
Yes, ma'am.
Hi, my name is Lisa Avidable. I just had a question for the representatives of Holtec. Do you live in any of the respected areas that would be affected by the evaporation or being put in the bay? Do you live in any of these areas?
I live in West Plymouth near the airport.
And so you
So
would be in the affected area?
within 10 miles of the
And you're
plant.
comfortable with letting this go into the bay, into,
Absolutely.
okay, and just because, is this because you work
And-
there
and-
and you
and-
have a stake in
No,
it
and-
because you work
and-
there?
and-
Is it-
and raising my children and
If you
taking
didn't
them to the
work
beach.
there and you didn't have a stake in it, would you want this happening in your backyard? Because I
I-
live literally right by the station. It's right down the street from me.
Right.
I spent every day outside this summer. I wasn't
Right.
going to let it stop me, even though I knew it was happening. But I thought about it, and I just feel like it shouldn't be happening. Releasing into my backyard where my child, my pets, my friends, my neighbors live. It just makes us all feel very uncomfortable. So I live right behind it in Sandwich, Sagamore line. And I can tell you, we are not comfortable with either way you feel you need to do it, whether it's in the air or in the bay. We are not comfortable with it, and we are not okay. All right? And we are going to share this message. This needs to be stopped. It's not okay. And you have a stake in it because you work there. And so I really can't take what you say. It's kind of bias, unfortunately. But you got to do what you got to do, and so don't we. So we are not okay. Thank you.
All right. The next item on the agenda is to elect a chair or vice, or coach, well, let me back a second. The statute that created this says, and I'm quoting, "The panel shall annually elect a chair or co-chairs and a vice chair for one-year terms." Mary and I were elected on November 27, 2023. Our terms run through, or to, depending on how you look at it, Wednesday. They certainly will have been expired by the time there's a next meeting. So we need now to elect a chair or vice chair, and also, chair or co-chairs, excuse me, and also a vice chair for a one-year term beginning on Wednesday, 27 November 2024. I have told everyone on the panel that I am not running for re-election. And I think a lot of people in the audience are aware of that, which leads us right now to, all right, I need nominations for chair or vice or co-chairs. Does anyone have a nomination? No, this is simply the panel. At the moment, I am taking nominations for chair or co-chairs, because that's the way the statute reads. Okay, so Pine is nominated, Ms. Gatzlick for chair. Do I hear any other nominations?
Yes, I have a fondness for the name of Mary, and I think Mary Lampert and Mary Gatzlick would make perhaps an odd couple, but guarantee a more balanced panel, because it is clear that Mary Gatzlick often represents one viewpoint, and I think it's clear that I represent more often the other viewpoint. And seeing as though the purpose of the panel is to appear really unbiased and recognize different viewpoints, I think that would make an interesting marriage. Don't look so shocked, Mary. It'll be all right.
I'm not shocked at all, Mary. Not one bit.
So I take that as a nomination for Mrs. Lampert and Mrs. Gatzlick for co-chairs. Is that correct?
Yes, that's a motion, correct.
It's not a motion, it's a nomination.
Motion as Mary
It's a
Waldron, who's not
nomination.
involved in all of this, so that's.
Excuse me, Mary. Could you say again, please?
I second that motion.
Okay, I don't think we need to second nominations, but thank you. So I guess that now leads us, if there are any other nominations?
I thought Mary Waldron was going to step up as, vice chair. Come on, the Trinity.
That was going to be my recommendation, a trifecta.
Well, I don't know what the trifecta's payoff is, but it better be pretty high. Okay, so basically, we had nominations for chair or co-chairs are closed. It's now time then to take a vote separately on those two nominations. It takes 11 votes to pass for either the two for co-chair or Mary Gatzlick for chair to ascend, lovely word, to that office. So let's start off by Mary's suggestion. I will go down the list. All in favor of electing Mary Gatzlick and Mary Lampert as co-chair, and we'll start with Mary Waldron.
I vote yes.
Yes? Mr. Gottlieb? Mr. Callahan? Mr. Wade?
I abstain.
Mr. Wade?
Abstain.
Mr. Bryant is not here, am I correct?
Abstain.
Oh, abstain?
Yes, sir.
Mr. Pickering?
I'll abstain.
Mr. Priest?
Abstain.
Mrs. Lampert? Yes?
Yes.
Mr. Canty?
No.
Ms. Gatzlick?
Yes.
Mr. Fortini?
Yes.
Ms. Dubois?
Yes.
Mr. O'Brien?
Yes.
Mr. Moylan?
No.
Mr. Noyes?
No.
1, 2, 3, 4, 5. I count 7 yeses. What do everybody else count? And I would vote yes, but that's still only 8. Does that agree with everyone else's count?
No.
So that nomination fails. Next vote is for Mary Gatzlick as chair. Ms. Waldron?
Yes.
Was that a yes?
Yes.
Mr. Gottlieb?
No.
Mr. Callahan?
Abstain.
Mr. Wade?
Abstain.
Mr. Bryant?
Abstain.
Mr. Pickering?
Abstain.
Mr. Priest?
Abstain.
Mrs. Lampert?
No.
Mr. Canty?
No.
Ms. Gatzlick?
Yes.
Mr. Fortini?
Yes.
Ms. Dubois?
Yes.
Mr. O'Brien?
Yes.
Mr. Moylan?
Yes.
Mr. Noyes?
Yes.
2, 3, 4, 5, 6. I see 7 affirmative votes. Is that
Yep.
agreed?
You're right, 7.
So that nomination fails also. So I guess the question is, and anybody's input would be welcome, now what? We have 2 terms that are expiring, and we do not have co-chairs or chair-elect for the term that begins on Wednesday.
I have a point of information.
Surely, I'll
Is-
try. We'll
Is
try.
the, I noticed that the state agencies have abstained. Is that because there's some requirement within the state that they abstain, or is that just a collaboration among the IWG that they should
I have
abstain?
no idea of that, and if they are free to explain it, if they wish, but
Could
I
you ask
would
them?
not ask them
Could you
to.
ask somebody, please?
If they are willing to explain that, that is fine. It is their right to explain or not explain their vote. Mr. Candy?
I think the committee would be, or the panel would be best served by having someone serve in the role of chair that does not have a particular perspective, either real or implied. So I would encourage someone to be nominated that the role of a chair is not to put a thumb on the scale, but just to facilitate an orderly meeting, allow the public to ask questions, allow information to be conveyed clearly and concisely in a digestible format. That is how the panel can do the best work to the public, getting that information out there and allowing folks to be heard, not by putting a particular perspective in or keeping a particular perspective out. So I would hope. I also don't think the idea of co-chairs is a good idea. The Roman Empire tried that. It didn't work out very well for them. I don't know why it would work out well for us.
Mr. Chair.
So I think it should be one chair, and he or she should be charged with conducting the meeting in an orderly fashion and letting everyone have their voices heard.
Mr. Chair.
Do you have a suggestion or a nomination?
Is
I
my
do.
question being
I do.
ignored,
I do.
Mr. Chair?
I think Mr. Canty just described himself. I would nominate Mr. Canty.
I was going to suggest the same, Mr. Chairman.
Okay, Mr. Candy, you have now been nominated. Let's go down.
Do you accept it?
I do.
Okay. Ms. Waldron?
Yes,
Oh, it was yes?
that
Sorry,
is correct.
The mic doesn't pick you up very well. Mr. Gottlieb?
Yes.
Mr. Callahan?
Abstain.
Mr. Wade?
Abstain.
Mr. Bryant?
Abstain.
Mr. Pickering?
Yes.
Mr. Priest?
Abstain.
Mrs. Lampert?
Abstain.
Mr. Candy, yes?
Yes.
Ms. Gatzlick?
Abstain.
Mr. Fortini?
No.
Mr. Bois?
No.
Mr. O'Brien?
Yes.
Mr. Moylan?
Yes.
Mr. Noyes?
Yes.
1, 2, 3, 4, 5. We have 7 again.
I think everybody's telling you, Jim, that they want you. A divorce is going to happen.
Are you doing this to me again?
No, just making an observation.
Do I have any other suggestions?
Now, what about just tabling it? You can handle one more, and people's moods might improve.
I'm not sure of that, but I guess I would ask unanimous consent of the panel to serve as acting chair, that I serve as acting chair at the next meeting, at which point we will begin the meeting electing a chair. Do I have unanimous consent? Very good. Let's go down, I got to go down the list again. Mary,
Yes.
Mr. Gottlieb,
Yes.
Callahan,
Yes.
Mr. Wade,
Yes.
Mr. Bryant,
Yes.
Mr. Pickering,
Yes.
Mr. Priest,
Yes.
Mrs. Lampert,
Yes.
Mr. Candy,
Yes.
Ms. Gatzlick,
Yes.
Mr. Fortini,
Yes.
Mr. Bois. Sure. Is that a yes or a no? It's a sure. No, I'm not counting sures. I need an aye or a nay, I'm sorry, but.
Oh, I abstain then.
Okay, fine. Mr. O'Brien? Yes. Mr. Moylan?
Yes.
Mr. Noyes?
Yes.
That is 14 yeses. I will vote yes. That would make it 15 with one abstention. I guess that's as close to unanimous as we're going to get, so that is the way I'm going to proceed.
Last thing is the annual report.
The last thing, we have one more item on the agenda, and it's the annual report. How are we going to handle it? Mary Gaslick asked that this be put on the agenda, so I'm going to ask her to take the lead.
I just want to get it out there to the panel members that, based on our track record for the past 2 years that I've been involved in it, we did not submit our report until May. It would be nice that if we, tonight, asked somebody volunteer to write it, because I'm not going to do it again, and also decide on what kind of format. Do we want to follow the same format that we did last year? Include all the presentations and everything else in their meeting minutes, that's fine. I just need the panel's opinion on what format and who's going to write it. I open it up to the panel for discussion.
You don't have to put up your hand to volunteer. How about starting with the format for everybody?
I'd suggest we do what we submitted last year.
Well, the final publication of the report, we're talking about what we submitted, correct?
Correct.
Thank you. I couldn't hear you because you're not speaking very clearly. I have a hard of hearing.
I would suggest we do what we did last year.
Okay, that's fine. Does the panel agree with that?
Yeah.
Okay.
Yeah. Everyone knows that I did not like that, but if the panel voted to do it before, it should vote to do it again. That's what the panel will do.
Good. That'll make it easy. Now, who's the person who's going to step up to the plate and pull it all together? Don't look at me.
And you don't look at me.
Not me.
Okay, think about that. It might not be as bad a job as anyone thinks it's going to be. And let's talk about that the first thing when we get together in January and hopefully get it done March.
Can only help.
Okay. I will entertain a motion to adjourn.
Before that, I'd like to thank Seth Pickering. He's done a really good job, and we'll miss him, and wish him best of luck.
Well, thanks, Mary, but you can't miss me if I'm not gone yet. We'll see.
I thought you were retiring.
Well, I hope to, but it may not be before the next meeting, so we'll see.
Oh, okay. Well, that's an early.
We certainly would need
Thank
your
you.
yes vote for something at the next meeting. Motion to adjourn.
So moved.
Second?
Second.
All in favor?
Aye.
We're adjourned. Thank you, everyone. It's been a long night.